Hello and welcome to this video. So in our last video, we have looked into some of the words like plain text, ciphertext, key algorithms and all those stuff. So we are going to look how we will go about going from a plain text to ciphertext. So how this works is, let's start with our plain text. So this is our plain text. So this is our plain text, and what happens is we have a person here. So this person is taking their plain text and using a key to generate a ciphertext. Okay, so we are having a plain text that is being converted into ciphertext, and that is being sent to. So this is the recipient. So this is the sender. It has a plain text. It converts into ciphertext, and the recipient gets it. So recipient, what happens is, uh, again this ciphertext gets converted into plain text, and then that recipient will get it. So how this will work? The plain text will go through an algorithm. So here it will go through algorithm. So here the plain text will go through algorithm with the key to encrypt and then convert it to ciphertext and then send to that person, and the same algorithm will be used here to. So then same algorithm will be used to convert it back to plain text. So in this video, we will look at one of the old algorithms called the Caesar Cipher. So I have my cyber chef. So we have a Caesar Cipher here. Yes, so I don't remember the spelling. Caesar Cipher S. So spelling is correct. Oh, I think. CyberChef doesn't have Caesar cipher. So okay, it doesn't have Caesar cipher. Okay, so let's see what a Caesar cipher does. The Caesar cipher converts our plain text into a cipher text. The Caesar cipher converts the plain text into cipher text with a shift operation. So what it does is it shifts the number of characters, uh, however many you want to shift. Okay, so let's say a is now converted into x, so it has a shift of around, I think, 24 or 25, 23. Okay, so this has a shift of 23, and then a is converted to x, b, y, c, z, and d, then it comes back to a. Okay, so this is how they convert our plain text into ciphertext, and this is used for encryption. So in old days, this was used at the time for encryption. So the quick brown fox jumps over the lazy dog gets converted to this gibberish. So at that time it was a little hard to break, but now it is very easy to break. It was a new logic at that time. So history and usage, you can see here how they used it. You can go through and read it, the wiki page. So let's find the site to convert our Caesar cipher. So this is the site we have for Caesar cipher decode online. So let's say this is my name, Rajat. So we have a shift here of 7. So we can have any shift. So this is 0 shift. So I get the same text. One shift, it converts, gets like one character up. So this is kind of easy. So if we give it like more shifts, this becomes a little bit more gibberish. So it is like, if you don't know what is being used here, it's a little hard to like find out what is being used. So next, let's do one thing. Let's implement this Caesar cipher in Python. So here I have created one simple project, crypto d. So let me create one file. So Caesar Cipher.py. Let's go ahead and implement Caesar Cipher. So for this, let's create a function called encrypt. So I think you can see this. So yeah, in this we will have a text that we are going to use, and the shift, how we are going to shift. Okay. So next, so whatever will be the output, we will keep it in the result. So we will keep an empty result here, and after that we will go through uh, our text. So this we'll use to go through our text. So for I in range, so we need to get the character right now. So our first character would be uh, text I. So this would be our first character. So there can be two scenarios for our characters. Character could be uppercase or lowercase. So first we are going to check if our character is uppercase or not. So let's we do this. Character dot is upper. Okay, let me check if is upper is correct. A dot is upper. Yeah, is upper is correct. Okay, so if this is upper, we will do the logic for uh, encoding upper character. If else, encode lower character. After that we will encode lower character and will return our result. So so for our upper character, let's first get the the value of the character in our ASCII code. So for that we can use like character code would be odd character. So let me print this once and let's see how we will build forward with this. So we know, okay, let's pass this one now and let's call our encrypt. So our text would be, let's say, Rajat itself, and I just want to go to three shifts. So let me print, sorry, not print, Caesar Cipher. Okay, it doesn't give me print anything because we need to go with upper characters, and I checked Python Caesar Cipher. So we got 82, 65, 74. This is the character we got for our RAJAT budget. So now we have the character code, and we need to shift. That means we need to add our shift to it. Okay, so let's see what our character code becomes. So we have added this character code, right? So the problem is we at the end of Z we need to go back to our A. So right now what happens is after Z it will go above Z. Okay, so if I print like this, let me give me a minute. Okay, character code we get, and let me print care of character code. Okay, so the values is chr. So you can see our R becomes U and A becomes D M Z. So if we go back to our online one and let's go there. So at our three shift UDMDW. So UDMDW. So it is correct, but what happens is if I put a Z here and then come back, so this Z becomes this character. So what we need to handle is we need to go back. So what happens is, like after 26 we need to go back to our 1. So it's, we have to add a modulus here. Okay, so modulus we will use. So what is modulus is a remainder we will get. Okay, so if I come here to explain you the modulus. So if 3 modulus 2 is 1, so 3 divided by 2 we get 1 as a remainder instead of, like, yeah, we will not go in points, so whatever the remainder we get we will take it here. Okay, so that is modulus to get our remainder in division. So let's get back to our code. So we shifted our character, but we need to handle a back condition. Okay, so now you can see we have added this. Okay, let's go and add modulus 26, 26, and we will see something good here. Okay, so let me add. So you see we get weird characters out, right? So why did this happen? So what modulus does is it converts, if uh, how would I explain is, modulus, if we add a modulus of 26, all of our value will be less than 26 no matter what happens. So if I go again in Python console, and you can see if I add 4, then modulus 26, it is 4. If I add 400 modulus 26, it's again 10 only, right? So no matter what value I use, it would always be less than 26. So we have 26 character, that is fine, we are good with that. But our ASCII characters, ASCII code doesn't go well with that. Okay, so our upper character starts from 65. So what we need to do is, after this we need to add 65 to it. Okay, so we have added 65 to it, and then again let's run it. So you can see it covers that. So HQZQJP, yeah, now again we got something weird, right? So for our Rajat value we should be getting UDMDW, but we are getting HQZQZ, right? So why I'm explaining all these weird things? Because if I give you just a solution, you will get the solution. It's a very easy thing. Okay, you can copy it, but these are the simple complication that makes it like a bit weird. Okay, so we have our character. So we got the value of our character, that is a simple 67, 82, something like that. We got with our on our ASCII code level. So for ASCII code, if you don't know what is ASCII code, you can read it here. I will put a link in below to see our ASCII table. Okay, so this is our ASCII table. Uh, yeah, okay. So you can see up to 31 we have these weird characters. Then after that 32 we started to get these symbols. Okay, 48 we got numbers. Then we have this. At 65 we started to get our upper character. So 65 is the upper character that's we used here. Okay, and then after that for our lower character starts from 97. So we will use it when we are going for our lower characters. Okay, so what is happening here? This is our character in ASCII. So what if we talk about R, capital R here? Let's say talk about capital uh, yeah, G. We have R in G, right? J 74. That is fine. We are using 3 shifts, so J should be 74, 75, 76. J should be 76, right? L 3 shift, right? 75, 70, 77. M, sorry, M. So J should be M. So this should be M after adding the shift. Okay, so if, stay with me a little bit. So our character, or our character for J, we are talking about J only right now. So J is uh, J is odd J. Okay, so the value of J is 74. So we added 74th. This is our shift. So becomes 77. So right now it is correct. So we have our character 77. We m, that is correct. We needed that answer. But right now what is happening is we are moduling 26, so we can get back. So what happens is 77 modulus 26. This becomes 25 now. Okay, and if I add 25 plus 65, now it becomes 90. But the answer needed here was 77. So something is different when we do modulus, right? So what modulus is doing is giving us remainder, right? So because of this we are losing our original value. So for keeping that original value, what we will do is we will play with this 65, because we are starting with 65, so we have to play with this 65. So this is our shift. Okay, so if let me remove it, add one more column here, let's go minus 65. Okay, so we are adding 65 here and let's minusing 65 beforehand. Okay, so let's go with the same value. We have our J value, so odd J is J, right? So in J value, sorry, not here. In J value I'm subtracting 65 beforehand, so that becomes 9. So now I'm doing 9 uh, modulus 26, so it should be 9, right? So and 9 plus 65, you can see it is 74, and our J is also 74, so we get the same value because we did this subtracting 65 beforehand. We got the same value. So what we can do is here we can add a shift to handle that. So same thing again, we have our J and J minus, we are doing shift minus 35. So shift is 3 minus 65, 136, right? Then we are going to do 136 modulus 26, 6. Okay, and then again we got 6. Okay, so then 6, 65 plus 6 becomes 71. Okay, this became, it got shift down instead of shift up. Did something wrong here? Oh, J we have, okay, here is plus, so I made a mistake here. So J plus 3 minus 65, that is 12, not 16. So yeah, so it become reversed. Okay, so then we become 65 plus 12 and we have 77 again. So 77 was the answer we were looking for. Okay, so this became our character code. So because of this modulus we had to do this. Okay, so let's do one thing, go back to our result and we will add our character code to it. Okay, so this should add our result. Okay, let me result equals 2 and then print result. Okay, okay, this is character code, so we have to do char here. Yeah, so this is the value that it became. So we can test it if it is correct here, and let me paste it here, 3 character UDMDWC, and this is the same value we are getting, right? So we have converted our plain text, that is this, into a ciphertext. So same thing would be with our lower code character. So let me copy and paste it. So character code, we have our odd character shift. Here we just one small thing, that we used is are the starting character would be 97, and here would be adding 90s. Okay, so that's it. This was the only change because of the ASCII table. So if I add Rajat in both small and capital, yeah, okay. So I got the same answer in small and capital both places. So go with Rajat. So we haven't handled spaces yet. Okay, so we are going towards character. We have a character. We are checking if character is upper or not. So let's add character if character equals to space. If that is the case, let's add result plus equals to space and then continue here. Okay, so yeah, we just handle our spaces there. That's it. Okay, so this is the code. I will place it. I I will place this on GitHub and provide the link in the description. So if you have any questions related to this, please let me know. Thank you.